All right, let's talk about a situation that I'm sure a lot of you have run into. You've just rolled out a brand new, super powerful Cisco SD-Access wired network. It's great, but your wireless setup is still chugging along on the old architecture. So how in the world do you get them to play nice together without tearing everything down and starting from scratch? Well, the answer is this really clever strategy called Wireless Over the Top, or OTT for short. So here's how we're going to break it down. First, we'll dig into the modernization challenge itself, the problem we're trying to solve. Then we'll get right into what wireless OTT actually is. From there, we'll look at some real-world use cases where this thing really shines. After that, we'll get into the nitty-gritty of how it's deployed and how the traffic flows, and then we'll wrap it all up with the benefits and, of course, the limitations you've got to keep in mind.
Okay, so let's start with the big problem, right? The reason we even need to talk about this. It's a situation that pops up constantly during network upgrades, and it creates this classic old meets new headache. And this is the question, isn't it? You've put all this time, effort, and money into building out this incredible, modern, policy-driven wired fabric. It's the future. But what do you do about that traditional wireless network that's been your reliable workhorse for years? Just ripping it all out and replacing it isn't always an option. So how do you bridge the gap between these two very different worlds? What you really need, what everyone's looking for, is a way forward that isn't some big, scary, all-or-nothing decision. The goal here is all about strategic integration. It's about finding a way to do this in phases, so you can start using all the cool new features of your fabric on the wired side while keeping everything totally stable and unchanged for your wireless users.
And that, my friends, brings us to the solution. And it's actually a pretty elegant one: wireless over the top. You can really think of it as the perfect bridge connecting your legacy wireless world to your brand new SD-Access fabric.
So to put it simply, what we're doing is taking your standard everyday wireless architecture, where the access points use a protocol called CATWAP to tunnel all their traffic back to a wireless LAN controller, and we're just running it right over the new fabric. The SD-Access fabric isn't trying to be smart about the wireless traffic. It's just acting as a simple, super fast highway to get it where it needs to go. And this diagram? It just lays it out perfectly. You've got your traditional access point on one side and the wireless LAN controller on the other. See that yellow bar? That's their CAPWAP tunnel, and it's just cruising straight through the SD-Access fabric cloud. The fabric itself is just a transport. It's providing a fast, reliable path from A to B, and that's it.
So that's the what. But how does this actually play out in the real world? I mean, knowing the theory is one thing, but knowing when to pull this tool out of your toolbox, that's the key. And it turns out this approach is super versatile and solves a bunch of common problems. First off, think of OTT as your get-out-of-jail-free card for migrations. If you want to modernize your wired network first and just leave the wireless side alone for now, this is perfect. It's also a lifesaver in big organizations where you have separate teams for wired and wireless, or maybe your hardware refresh cycles just don't line up. At the end of the day, it buys you time and lets your teams get comfortable with the new fabric without any pressure. But hey, OTT isn't just a temporary patch. For a lot of folks, it's a completely valid long-term solution. For instance, maybe you're heavily invested in a third-party wireless solution from another vendor. OTT lets you integrate it seamlessly. Or maybe your current wireless gear just plain doesn't support a full fabric integration. In situations like that, OTT gives you a super stable, permanent way to get the benefits of an SD-Access underlay without having to touch your business-critical wireless network. All right, time to roll up our sleeves and look under the hood. Let's peel back the layers a bit and see how you actually deploy this thing, and more importantly, how the data packets actually find their way through this hybrid world. So, step one, it all starts with your wireless LAN controller, the WLC. Now, notice here it's sitting outside the SD-Access fabric. It connects to what we call a border node. The really crucial step is advertising its management subnet into the fabric. That's what makes the WLC reachable from anywhere inside the fabric. Okay, now for the access points. You literally just plug them directly into your fabric edge switches. That action places them inside the fabric's overlay, usually on a single management VLAN. And because the APs are now inside the fabric, and we've already told the fabric where the WLC is, well, they can discover the controller and build that all-important CAPWAP tunnel right across the fabric. And this right here is the absolute most important thing to understand about this whole setup. From the point of view of the AP, and from the point of view of your wireless laptop or phone, the SD-Access fabric might as well not exist. It is a complete black box. All they know is they have a clear path to the WLC. All that underlying complexity, the VXLAN, the Lisp, the whole fabric shebang, it's completely hidden from them. So how does this magic actually work? Well, when an AP sends out a normal CAPWAP packet, the fabric edge switch it's plugged into does something clever. It wraps that entire packet inside a VXLAN header. VXLAN is the secret sauce that makes SD access work. So you've essentially got a tunnel inside of a tunnel. The original CAPW packet is the cargo, and VXLAN is the shipping container that carries it across the fabric. Now, once that VXLAN wrapped packet makes it to the border node, think of it as the exit ramp of the fabric. The exact opposite happens. The border node just strips off that outer VXLAN header, which reveals the perfectly preserved original CAPWAP packet inside. It then forwards that packet onto the WLC, which has no idea it just took a ride inside another protocol. This diagram is great because it puts the whole flow together. A wireless client sends its traffic, it gets tunneled via CAPWAP to the WLC, which is outside the fabric. The WLC then turns around and routes that traffic back into the fabric to reach a wired server or computer. Now, you might hear this called tromboning because the path goes out and comes back in, kind of like a trombone slide. But in this architecture, it's a perfectly normal, predictable, and well-managed flow.
Okay, we've covered a lot of ground. We've seen what it is, we've seen how it works, so let's wrap this up by looking at the big picture. We'll summarize what this architecture gives you, and, just as important, what the key things are that you really need to watch out for.
And this slide, this is a great little cheat sheet for the whole thing. It visually points out all the key components, the common AP subnet, the fact that you need to think about MTU for the fabric path, and how it's just a standard, familiar config on the WLC side. Let's break these points down just a little bit more. So let's just lay it all out. On the benefit side, the list is pretty compelling. You get incredible flexibility. You can use any AP model you want, even third-party ones. Operationally, it's often way simpler, letting you use a single IP subnet for all your APs. And you don't have to worry about immediate AP or WLC software upgrades. Now, for the limitation, and this is the main technical gotcha, you have to increase the maximum transmission unit, or MTU, on the network path. That's just to make extra room for that VXLAN feeder so you don't chop up your packets and hurt performance. And that really leaves us with one final big picture question to chew on. Wireless OTT is an incredibly powerful, incredibly flexible tool for migration and for integration, no doubt about it. But it does mean you're using your advanced, policy-aware fabric as, well, a simple transport layer for your wireless. So the question you have to ask yourself is, does this align with your ultimate vision for a fully integrated, end-to-end, policy-driven network? It's a fantastic bridge, but you just need to decide if it's your final destination.